In this video, I'm going to show you how to complete the square to solve a quadratic equation. So what does it mean to complete the square? Well, in this example, we have two quadratic expressions, and I want to add a constant here to convert these expressions into perfect square trinomials. And the way we do that is you look at this middle term here, 6x. You take the coefficient of 6 and you take half of it, and then you square it. So half of 6 is 3. 3 squared is 9. And you're always going to add that constant. So I'm going to add 9. What this does is it creates a perfect square trinomial, and it's x plus 3 squared. And this number here is always half of your middle coefficient. Here we have -1 as our middle coefficient, and so we take half of -1, becomes -1/2, and you square it, you get 1/4. So I'm going to add 1/4 here, and that will give me x minus 1/2 squared. Now, this works by taking half of this middle coefficient and squaring it. Only works when you have a leading coefficient of 1, as we do in these two examples. You have to do something different if you have a different constant other than 1 as a leading coefficient, but I'm not going to worry about that right now. I'm going to do some examples where we use this idea of completing the square to solve quadratic equations. Remember, these are not quadratic equations. These are simply expressions. When you have an equation, of course, you have an equal sign. And here in example 2, we have x squared plus 4x equals 17. So I want to complete the square here. I have x squared plus 4x. And I want to take half of 4, that's 2, square it, that's 4. So I'm going to add x squared plus 4x. I'm adding 4 to both sides of the equation. Here, I'm adding 4 to create a perfect square trinomial. And then what I've done to this side, I also have to do to the other side. So I'm going to add 4 to 17, and that will give me 21. Now, this becomes x plus 2 squared, and the right side is still 21. And now I can solve this by taking the square root of both sides using the square root property. And what this gives me is x plus 2 equals plus or minus the square root of 21. And then to solve for x, I'm going to subtract 2 from both sides of the equation. And that gives me x equals -2 plus or minus the square root of 21. Now, in this example, notice I have that coefficient, and we're going to just go ahead and move the constant, this -1 out of the way to the other side of the equation. So I'm going to add 1 to both sides, and that gives me 2x squared plus 3x equals 1. And I want to get rid of the 2 as well. So I'm going to divide both sides of the equation by 2. And that gives me x squared plus 3/2 x is equal to 1/2. Now, to complete the square on the left-hand side here, I'm going to take half of this coefficient, and that half of 3/2 is 3/4, and then I'm going to square that, and the square of 3/4 is 9/16. So I'm going to add that to both sides, so I have x squared plus 3/2 x plus 9/16, and since I've added it here, I also have to add it to the other side of the equation. And now this becomes a perfect square trinomial. So this is going to be x plus 3/4 squared. And in order to add those two fractions, I'm going to find a common denominator of 16. And so I have 17, because I have 1/2 times 8/8 gives me 8 plus 9. That's 17 in the numerator, and then 16 in the denominator. And now I can go ahead and use the square root property, and I'm taking the square root of both sides. And I get that x plus 3/4 is going to equal plus or minus the square root of 17 over 4, because when I take the square root of 16, I get 4 in the denominator here. And now I can subtract 3/4 from both sides, and that gives me x is equal to negative 3/4 plus or minus the square root of 17/4. And that is how you use the method of completing the square to solve a quadratic equation. By the way, this method is how we get the quadratic formula. And when we're doing that, we're using the form ax squared plus bx plus c equals 0. And we just go ahead and carry the constants through the process of completing the square, and then you end up with your formula.